All right. And here we are. Hello, everyone, and welcome to another episode of Amplifying F#. I'm your host, Jimmy Bird, and today we're going to be joined by Florian and David about FSharp.Analyzers. Go ahead and share my screen for this. So you may be wondering, what is Amplifying F#? Amplifying F# is an initiative to encourage hands-on collaboration with open source F# software, so things like the tooling or any open source project that makes F# better. You can help us by clicking the Join Us Today button. And here you can specify, like, we just kind of ask some information about you so we can schedule a session with you. And so this would be your name, your company, if there's a company available sponsoring, your time zone, and the topic. You can also see previous sessions if you come over to our sessions page. You can see what we did last week, which last week we luckily had the F# team on, and we were able to talk about what was new in F# 8. This is a great resource. Definitely recommend watching this if you haven't watched this already. And with that, I will start talking about this part. This is the F# analyzers. F# analyzers are basically this concept that we need some type of additional processing on top of our code, things that the compiler doesn't give us. And luckily, Florian and David have taken up the spot of being able to champion this. And so I'm going to turn this over to them so they can talk more about this.
All right, thank you. Let me get started. So we have a couple of slides for today. Hi there, I'm Florian. Together with my colleague David, we've been working on the Ionite SDK for analyzers. So we're quickly going to skim through what are analyzers and what do we sort of mean with them, the state of F# analyzers, why G Research as an organization was invested in this, and then just give like for the remainder a good demo. So analyzers sort of inspect your own code, and you typically they work in like a rule-based fashion. And if you break the rule, then some tool sort of yells at you that you either did something wrong, or something that's even the code compiled was fine. You still might have some runtime issues, or you're just doing something that's not according to some team agreements. And you basically want to check your coding quality or your code style with a certain set of rules that you sort of run against your own code. That's in a nutshell what we mean with analyzers. In .NET, analyzers currently are like the Roslyn analyzers because they are tied to the Roslyn compiler, which is for C# and VB. F# isn't powered by Roslyn, so there's no real story yet for F#. But it pretty much is on the radar, or that's at least what we believe for F# 9. So we'll talk about that a little bit as well. And we found this in the project tooling board, like F# 9 Analyzer SDK. And it's a pretty empty issue, but it sort of indicates that the team might probably pick it up for F# 9. And this is no critique to the team for not providing, more details, but I sort of feel like this is a very large topic, and there's a lot of room for innovation. That this is all a bit of a brave new world kind of scenario. And from my point of view, we should really try and access this at the community and see how we can get like the best support for analyzers in F# 9. Now, because I'm not known for my patience, I was wondering, can we not do something today? Because F# 9 will probably release somewhere next year in November, because at the time we're recording, F# 8 isn't really available yet. So I was wondering, is there nothing else we can do that sort of mimics what Analyzers does? And there is the Ionite SDK, which was created by Christoph Fieslak in 2018, and it basically was a sort of the F# open source take on Roslyn, and it's more or less I think launched in the same time span, give or take. And there was a way to sort of run analyzers, and we noticed that the SDK wasn't really up to date. It didn't have the latest compiler. So David and I, as part of our mandate for the open source team over at G Research, started looking into that, trying to improve the i9 SDK so that we bring it back to a state where we can prototype some ideas. We really want to sort of try out some analyzers today to sort of help shape the future of what analyzers in F#9 could be, to really test some ideas we have for analyzers, and then see if we can sort of make it happen in like the official support, or how that looks like, and just really gather some input to sort of as a community get into this together and see that we can make the best out of it. We've also added a little bit more documentation on FSharp analyzers. So everything we do, we really do try to document and really engage other people to sort of chime in. Please play around with this, read the docs a little bit, get a sense of what the SDK can do. And yeah, we'll sort of wrap up with the F# analyzers 5G research. So we've written a couple of analyzers ourselves using the latest version of the SDK. And the analyzers that the research wants us to create are things that they actually encountered in production. So they're problems in terms of performance or something that could have been avoided during a code review. But sometimes when your PR is massive, you probably might not spot everything. And that's where if an analyzer runs automatically on your CI job, it just can really help catch you things before they go into production, even if the code compiles just fine. So all in all, we just really want to help to shape the future of FSharp analyzers in one way or another. And the practical way for us to do that was by investing in the i9 SDK. And now let's talk about the good stuff. I'll give it to David for a first demo.
Okay, thanks. Let me share my screen. Okay. What you can see is ongoing documentation work by Florian and me. It will be published really soon. But what we want to do in this demo is walk users of analyzers through how to get started, and also walk potential authors walk through how to get started with authoring an analyzer. So we start with the user side of things. You can go to the repository and find this documentation published really soon. So there's a CLI tool to run analyzers in your CLI, because we have two big use cases. One use case is integrated in your IDE, and the other use case is running an analyzer on a command in your CLI. So what I will show you is like the simplest first approach as a user to get started with using the CLI tool. I have this very simple project called FET. It consists just of two projects, a logic project and a test project. Just a couple of code files, so it's a good example for integration of analyzers. So first things first, we have to add the tool to the tool manifest. It will already be there, but yeah, that's how you do it. Latest version is 0.17. And the next step, you just have to follow along the documentation, is add the NuGet package of your analyzers to your project. So we assume that your analyzers you want to use are distributed as NuGet packages, because it's the easiest way. So you copy the package reference and go to the project that you actually want to have analyzed, at the package reference like this. And that's basically all you need to do. Of course, the package DLLs have to be on your disk, so you have to do a .NET restore, for example. And then you can use this command line here to run the analyzer against your local project. Let me go to the project folder, and I need to adjust some of the arguments. So of course I have another project file here, so that needs to fit. And I also have to make sure that the path to the NuGet package cache is correct. And if all this lines up, you can see that there were actually 6 analyzers loaded from the DLL contained in the package. And you get, yeah, on your CLI, the warnings of the analyzers. So I added a demo file for demo purposes. You can just click on it and yeah, you can see the location, the range that the analyzer complained about. Here, for example, it's a partial application, which can be problematic in some contexts. So there's an analyzer for this in the G-Research package. And the next one is a bad usage of the strings API, because yeah, there's a lot to using the string API in a correct way. Educate yourself about it. Yeah, and now you just have to click on the warning and you are at the right position. So that's really simple. Like you add the package to your package reference, you add the CLI tool, you have to fiddle a little bit around with the path, and you have analyzers in your project. But of course, this is like a super simple context here we are working in. This is a very small solution with just 2 projects. And you can imagine that this doesn't scale really well if you have a solution with hundreds of projects. And that's also solved in a way already. And Florian will show you how you can do it in a more complex solution setup.
All right, before we skip, actually,
Yep.
all right, now could you maybe circle back real quick? If you go to the FS Proj, so there's something else that looks a little bit, so the private assets, that's really just to tell like NuGet that you don't want this DLL of the package to really be part of your own solution. So there are a little bit of little things which we took over from like the Rothman world, where you do want to say that your analyzer is private, well, that the assets are private, and that you sort of want to specify that an analyzer. If you were to go to the G-Research Analyzers NuGet page, there's even a little bit more, of, MS build props there, and we sort of use these things accordingly to Rothman, and
it's in the
yeah, if you press, yeah. So there's a thing here, but if you go back to the home page and then sort of click on the NuGet button, there's like a toast banner thing at the top. Yeah, NuGet 016. If you scroll to README. Sorry, the top of the README file. Sorry. If you just scroll a little down. Yeah,
okay.
then there's NuGet. You want to click on the NuGet button. That's the link. There we go. So yeah, it just really gets you the correct text which you need to include, and you can notice that the word analyzes is already in there. So that's just really the way we're trying to mimic and get the SDK as close as possible to the experience that is in Roslyn today. So if users are already familiar with it, should a little bit feel at home.
That I noticed. I forgot one other simple bit. So if you don't want to mess around with the rather long command and the path to the DLLs and stuff, you can also add a custom MS build target. Yeah, you can just copy and paste it because authoring these is not the simplest thing. But here we are making use of something that NuGet provides. It's a variable that is also processed by MS-Build, and the whole path to the NuGet cache on my machine is behind this variable, which is really convenient. If you want to see how this thing is really called, because it has to be normalized a little bit to be able to be compatible with MS-Build, you can have a look into your NuGet gprops file, and yeah, you will find it in here. But with this in place, we can do a .NET MS-Build de-analyze project, and okay, it should have worked.
Show the props file from NuGet again?
Yeah, might need to restore. Yeah, the props file had to be constructed, and yeah, now you can just invoke the custom target for your project in the project folder if you do it like this. And yeah, the same will happen as this long CLI command. So yeah, another small step to make the usage simpler for you. But yeah,
you could also place a dependency on like the restore tasks or targets. Not sure if that'll be too much performance hit on bigger projects, but you could do that as well.
Yeah, there's definitely room for more improvements regarding all the MS-Build infrastructure. Yeah, we are far from finished in this direction. Yeah, but yeah, as I said, to see how this is done in a bigger, more complex solution, Florian will show how we did it in CentOS in the last couple of days.
Gotcha, thank you. So in CentOS, we basically did more or less the same thing. Like we have multiple projects, and we also thought about, oh, can we add like a target? But instead of adding it to each individual project file, we actually added it to something called a directory build target. And everything you specify in your directory build targets will also be available inside each individual project file. And right there, we created the same analyze project, but we tried to be clever and did something slightly different. David explained to you that you can pass in .NET Analyzers project, but if we go and look at the help, it is also possible to pass in the raw FSharp compiler arguments. And MS-Build actually collects these things. So it is possible to do what we call a design time build. And we do that by, depending on actually a lot of targets, and some of them have name of design time. And, this is all good, interesting stuff that we were able to sort of steal from Projinfo cracking. So there are a lot of smart folks that sort of did this before us. This is really the bread and butter of what INI does to sort of get IntelliSense working. And the clue is that to analyze a project, we need to do a design time build because we're basically after the same information that the compiler has when it type checks your files, but we cannot hook into the compilation of FSharp, which is something I assume it's more or less going to work maybe for FSharp 9. But we need to sort of mimic the same thing, do the type checking, and to do that, we need to pass in all the arguments to the compiler. When you do it with the project flag, that is something that we're going to use Projinfo, and it's going to figure it out how it does that. It's going to call them as build for you. But we found out that actually, if you're doing a regular build, we already sort of do this, and you can have like a cached version of that. So I'll just quickly skim over this, but the clue would be that we're going to run analyze project. We're going to depend on the other target. So all these things will run before that. And then we're going to find the arguments over here in this item STS command line arg. And we're basically also just going to point to the same package. So it's pretty much the G research analyzers that work these days because we changed the SDK recently. So that's really the good example to play with right now. And we're just going to invoke it like that. And if we then try to do that, so let's do a .NET builds, I'll just skip this for now and I'll say, because it's in my props directory build props, it's also available in like each individual project. And I'm going to try and run analyze project for Phantom's client. Now that failed, and that actually failed because it requires a little bit more of MS build finesse, so to speak. We really want to invoke the design time build, so we need to add in a couple more project properties. One of them is like, hey, it's a design time build. The provide command line arguments needs to be true because that's actually what's going to populate this. And then we don't want to invoke the actual compiler, so we say skip compiler execution. So what this does is it essentially constructs a lot of MS build magic and gets the like a .NET build experience up to the point where it passes everything to the compiler, and then the compiler is just not going to do anything with it. It has all the correct arguments, but it is not going to invoke an actual build. But because we are at that stage, we sort of collected all the compiler arguments, and then it's going to be able to sort of run our analyzer. So this was a little bit advanced, but you can see this was pretty fast. And the reason for that is that MS Build is able to cache these things. So that's why it's very convenient to sort of do this. Now actually prove that this is working, let me try and add a something that the analyzer will warn us. So we talked about it a little bit. If you use ends with, the analyzer is going to complain about that. So let me just ignore that real quick. And the problem with ends with and just like a single string is that it is actually preferred to call ends with and then string compare order, I think.
Comparison. String comparison.
String comparison, yes. So if you invoke it like that, it is better for reasons. And this still is a bit of a new thing to me, but you'd be surprised how many times you actually write code like that and not think about it. So that's really where an analyzer can definitely help spot you these things. Because I write code without thinking about this all the time. And that if we run this again now, we're going to see that the analyzer didn't trigger. So that is one thing, but then I'll put it back in and I'll put it back in, but now I need to run this for my client project. Then you can imagine, oh, I need to run this for the next project, et cetera, et cetera. So what we try to do is orchestrate like an invocation of this target for all the projects. And we did this with calling a directory solution targets. This is another MS Build kind of gimmick where we are able to like run a target, but at the solution level. We can now do a .NET MS Build and put in a target like this, analyze solution, and then it because there's a solution on this level, it will sort of hook into this target and execute it. What we do here, we first do actually a full build of our release pipeline, of our release build. And why do we do that? Because when you have dependencies on individual projects, so Phantom's core depends on Phantom's FCS. If we are going to do the analysis for Phantom's core, we actually do want the Phantom's FCS binary to exist because the information, the type check is going to be coming from that. Don't overly worry about that, but within our CI process, we actually already know that this is going to be built, but just as a safety, we invoke it again. And then we call this MS build, which takes in our project to analyze, which we defined over here, and that just says, hey, grab all the FSproj in the source folder, but exclude this one because we don't want to analyze that. And for all those projects, call these targets. This target analyze project was defined earlier. And we can actually pass in the bunch of the properties that we did from the command line earlier. So we don't need to specify anything. and we can just run this, and it should all just magically work. So the first thing it does is going to do a release build of everything, which is happening pretty fast. It already did this. And now it's just going to invoke all of it for my analyzers. And another thing we do for Phantomus is we specify the -- report flag in our build target. And the report flag allows you to construct something that's called a serif or serif file. And that basically is a piece of JSON that can later be picked up by tooling to sort of indicate what went wrong with the code and then give you an overview of that. So we noticed that the MS build had failed. We wanted to fail because we want our build to fail because our analyzer reported something. And if we now try and take a look at the exported serif files, we'll take a look at line. So this is a piece of JSON, and it's basically going to tell you what are the results of the run, what kind of tool it invoked. So it is invoked analyzer, init analyzer CLI, but you could imagine that multiple things happened here. And in our case, we're going to say, hey, your string usage result was with a single argument was discouraged. And we would tell it exactly which file did it happen and where, what was the region. And for the rules itself, there also is a bit of a description, some metadata about what happens. And I'll just open this link real quick if I can. It's about the best practices for string, so we're really not making this up, but I'm definitely not in the best disposition to sort of educate the masses on this. In essence, there's like recommendations for string usage, and use an overload to explicitly the comparison rule for operations. So this is typically invoked by calling an overload, and this is just something that the people over at G-Research had encountered. So that's why we created the analyzer. We have the serif file, and I sort of propose we'll just commit and see what this does. So I'll give the screen back to David to sort of talk about creating an analyzer, but then we can circle back and see what does this do during a CI run where we invoked it. Because when we go to GitHub Actions, we can see in our workflow that one of the things is actually just to upload the serif files. So we have this upload serif file, GitHub CodeQL action, and that sort of integrates the whole analyzer story in your GitHub. So your build is basically going to tell you, hey, you broke these rules of your analyzer within your GitHub. So it takes a couple of minutes to sort of pop up. So I'll just prepare that behind the scenes and just give it back to David real quick.
Okay, thanks. Okay, as I said, the second part of the demo will be writing an analyzer. Again, the documentation is out there. You will find it. As we already said, there's an SDK. We put in a lot of work in the last couple of weeks to modernize it, make the usage for authors simpler. And we created the first somewhat serious analyzers package called the G-Research FSharp.Analyzers. But to walk you through how to author an analyzer, we will do something simpler today. If you search for some idea what to write, what kind of analyzers to write, you can go actually to the large list of Wassland analyzers and pick a random one and try to port it over to FSharp. I did this for CA 1820, the test for empty strings using string lengths. This is about testing a string just in a naive way if it's empty. If you do it like this, compared to the framework provided is null or empty, you actually end up with a little bit of not quite as performant code as you could be. So you see here in M1, the empty string is loaded first, and then the compare is done by calling equals. And with the M2 implementation, there's no empty string first loaded, and yeah, you kind of save one instruction, and it's yeah, if you do a lot of these things, yeah, there's a small chance for performance wins. So it's kind of nice to have these things as an analyzer, and that's what I did here in the empty string analyzer. Again, you just follow the documentation. You create a class lib. .NET 6 is a pretty safe bet currently. You add the SDK package to your project with the package manager of your choice. And yeah, you should make sure that you are targeting an exact version of F# core to be really compatible with the FSC we use in the SDK to be binary compatible. And if you have these things in place, the next step is to implement a certain interface, which is basically taking in an analyzer context, which provides you with the needed information to run your analyzers on. And there were two kinds of contexts. There's the CLI analyzer context and the editor context. And the difference is the CLI analyzer context has all the information already present, and you can just start analyzing things with it, while the editor analyzer might not be fully populated yet, because you can imagine that providing the type tree every second after every single press of a button is not the most performant thing to do. So there might be analyzers which should run only after certain actions like saving a file or building or something like this. So we have this kind of two-tiered approach to this. But yeah, the simplest start for authors is the CLI analyzer. You get the context. In there, you can see you have the F# check file results, the check project results, the file name, and so on, the type tree. Yeah, we think currently this is enough for most analyzers. Maybe more will show up, but so far it's a good amount of information. And yeah, then you can write just normal analyzing code depending on your use case. In this case, I'm looking for empty strings in a comparison. So I look if a call happens to the operators equal, and if this is the case and there's an empty string involved in this, I raise an issue. I raise a warning. And how do you raise a warning? The return type of the interface you have to implement is a list of messages of this type. You have various information in here, like which range is actually warned about. The message which should explain the issue to the user, a code which you can actually use in the CLI integration of analyzers to maybe treat a warning as an error or to ignore a certain code or ignore an analyzer altogether. you can use these informations for customizing your integration of analyzers. So there are the G research analyzers are open source. So if you want to see pretty elaborate example of usage, how to implement analyzers, you should go to the repository and have a look there. We also extended the SDK in the last couple of weeks to make testing easier. So there's a second package called FSharp.Analyzers.SDK testing. Make sure that you use it in the same version like the SDK. These should all line up. And there are helper functions in there, like message contains, for example. It takes in the message you are expecting. You put in the message that you got back from your analyzer. And it will give you a Boolean return to help you write tests. Of course, these assertion helpers are agnostic about the used unit testing framework. That's still up to the author. But we hope it makes the testing story a bit easier. But really the main bonus point that gives to you is what happens in the setup here. In the testing, in the SDK testing namespace, there's a function called make options from project. And like you saw in the user demo, it's pretty complex, or it can be pretty complex to get the correct F# project options. And you also need the same thing for setting up tests and running tests. So it is if you do it on your own, you will sometimes think, okay, this is an easy way to do it, but then you switch to another operating system and it stops working, and you switch from one framework version to another and it stops working. So there's unfortunately a lot to it, and we hope to make the testers' lives a lot easier with giving you this helper function called make options from project. You say which framework you are targeting. It currently supports all what your local machine supports. And here you can also give a list of NuGet packages, including their version, because if you want to use a certain API from some NuGet package in your test, of course, this has to be compilable and type checkable. And so the project options we are constructing here also take this into account. So you can just use the namespaces of some NuGets in your tests. So that's basically it. The simple empty string analyzer is also public in my GitHub account. It's a pretty simple one if you want to get a simple idea. Take a look at it. And now I think the Zarif integration has happened.
Yes and no.
No?
Actually, a little bit more no. But let's maybe just fix it as a group. There's a little hiccup we didn't take into account. Let me maybe share the screen back and I'll sort of talk through. So it was working, and then we sort of switched the whole thing to MS Build, and well, we didn't really test it thoroughly again. So the problem we have right now is that our build failed because it tried to run the analyzers, and our build failed, so it didn't get to the point where it's going to upload the Serif file. So there's a little bit of GitHub actions which we'll have to do. So the solution, real quick, would be let's not run the analyzers over here. Let's just comment that out. Comment out a couple of things actually. Build run any unit tests. Fine, just so that we can sort of speed up the main thing. Let us also not do a benchmark. Again, just to speed things up. So inside of build, we're going to our fun build scripts over here, and we're not going to analyze there, but we're going to analyze over here. So we're just going to invoke that directly. There's one thing we also need to take into account, and it's going to be we'll need to create the analyzer analysis thing directory because that doesn't really happen right now. So just copy that as well. And yeah, if people spot me on typos, please let me know. And the thing is that we'll need to say to GitHub Actions that please continue when this failed. And I have no idea how to do that just yet. So off screen, I'll try and Google that real quick.
I think it's like an if always check because I've had to do something like that before.
Continue on error true. So let's just do it like that. And yes, I believe that's don't do things here. Speed things up. We don't benchmark. We run the analyzers. It's gonna fail, but that's fine. And that should probably do it. There we go. And let's take a look. So while this is running, I can actually quickly show you just another demo we had in mind. There also was a little hiccup this week in the FSharp compiler that a certain warning, which is now produced by .NET 8, like the new compiler, when you have a record update where you're updating all the fields, it's actually recommended that you that you just create a new record altogether. And this was causing a lot of warnings for multiple customers. And then I sort of figured out like where is the boundary between something as part of the compiler and something could have been an analyzer. So I was just curious, could I make this new feature, which is now happening in the compiler, as an analyzer? So to give you an idea of what I'm talking about, let's do .NET Interactive, and I think that's going to be fine. Let me just really quickly go to a test example I had over here. Let us paste it. And I probably need a lang version thing over here. So lang version preview, maybe. Definitely spitballing this. There we go. So the compiler now gives you this warning, like this is a copy, an update record, and all the fields are changed. So it just makes more sense to create a new instance of R instead of doing the updates. This is something that's in the compiler, and I was wondering, could it have been as an analyzer as well? And the way I started sort of approaching it is you need to create a CLI analyzer. It needs an attribute get picked up. So that's all a little bit of registration goodness. It takes a context. And the first thing we're going to do is just we're going to look into the current file and see, can we find some update record from the untyped AST? So I kind of know my way around syntax tree. I check for a records. I check if it has copy information. And if this AST node matches, then I know I am in the X with case because, well, X will be part of sum. And I'll just take all the fields that are updated into account and capture the range. But at this point, I do not know what kind of a type that is. So the next thing I thought, oh, why can we not reverse the type tree? And there, we're going to gloss over a little bit, but you can sort of see that this is still a little bit early days about what the Analyzer SDK offers. There's a file we copied from our other project, from the G Research Analyzers, and this walks over the type tree in a sort of visitor kind of way, and it will sort of react over here. It will just react in terms of what when it hits the records declaration. So look for something like new records. If it finds a new record instance in the pipe, it's going to invoke my handler function, which I'm passing down. So we're really doing type tree traversal, and there's no good way to do it today. So that's where we're really are testing the ground, and then we need to come up with some more building blocks for analyzers because this is a problem more people will have. But for now, let's just go with it. We sort of collected the untyped tree part, then we're just finding, is there something in the type tree where the range is the same thing as I know, which was an update? So I'm kind of puzzling those things together. And in my handler over here, if there's, I'm actually getting a note which I know is an update as a new record. I match if there's any untyped record that matches the types, then I kind of know, oh, these are together. Then basically I'm going to look at, hey, the type definition, was this thing an F# record? And if it was, is the type definition having as many fields as the fields that are overwritten in the untyped tree? And if that is the case, I'm just going to add a message and say, oh, all the record fields are being updated, consider creating a new instance. So this definitely is, probably not a bulletproof approach, but will most likely work for like 80 to 90% of the cases. And when we take a look at some of the tests here, let's actually maybe debug that to see what the experience is like. So you're just basically going to invoke your analyzer with a context. It's going to walk over the syntax tree. It's going to walk over the type tree. Okay, so it finds a expression. It is indeed a record, but it's not having copy information, so it skips it. And it's just this collector thing is also a little bit of custom code that we have to mimic what the syntax visitor today does, but do it for all possible nodes in the file. The second time it will actually hit this because we're doing the update records. Over here, yes, this is the one. And it will try and eventually match this. So it does matching on multiple levels because the type tree does invoke new record a couple of times. But then it found a match, and then it sort of looks at it an F# records are the fields defined in the type the same amount of lengths that are overwritten. And then we're going to add the warning, and then we get the message, and we can do some assertions of our message inside of our unit test. And this really just proves over time that this will keep working. That's sort of the nice part. With the project options, I just went with something net 7. Then we also just have another example. What if you have multiple record fields? Like, was I lucky with a single test? I would try and see, increase the number of fields. And then also trying to add a negative test. So right here we have 3 fields. And if we only override 2, it shouldn't warn us. And yeah, you can already kind of see, but all the tests sort of pass, which makes this really a novel experience to write your analyzer. You don't need to invoke the command line and see if it did something or not. You can just really test and build up, and it's very nice to explore your first use case and then just come up with more scenarios of things you want to test. Or if you notice that your analyzer was kind of working, but then in production it didn't trigger for some reason, then you can sort of try and dissect easily why that was the case. While that is running, let's see if we're already doing good things here. Okay, it looks like we're running the analyzers right now. Okay. And then the Sarah file will be uploaded, hopefully in a minute. Come on. Okay, that just didn't work.
That shows them in another repo.
Yeah. Do you have an example there?
Yeah.
Yeah. All right. Great.
All right. Yeah, basically we did the same already in another repository. Just for quick reference, here's the upload, just as Florian showed you. And during such a one, you will see the upload. And yeah, the interesting thing is that there's a pretty great GitHub integration for Serif files. If you upload such a thing, you will get messages in your PR from a GitHub bot. And yeah, if you follow the links that it offered you, you will get an overview over the warnings. And in the PR itself, you can also directly see the warnings. And for example, here, as we explained, there's a warning about the starts with API usage. And if you go to details, you will get more information about the exact code of the analyzer that you as an author gave back, or the author you used gave back, and the message is seen. And yeah, that's in our opinion a pretty decent integration into GitHub code quality infrastructure already. Yeah, just by uploading this simple Serif file. Yeah, that's basically the story to Serif currently. Okay. Anything to add, or
Let's maybe
no?
circle back to the documentation website one last time.
Yep.
So all the stuff we sort of told you right here, right now, should be more or less available. And we really encourage people to, start trying this out and giving us feedback, because there definitely are gaps, or there are points that are less convenient to use, or where the developer experience could really improve. And yeah, we just really want more people to sort of interact with this and see what we can do together. If you're missing documentation, let us know. Or if you're starting to play and write your own analyzer, but you just have a question, this is my code sample, and I want to see how do I get to this. For example, how do I get to the return type of a function? If you have questions like this, please raise them as well. We'll be happy to help you and see if we, can assist you, and maybe even write some more generic building blocks of getting the typical use cases easier. Um, so yeah, please reach out to us, engage, and we'd be happy to chat with you.
All right.
Awesome. That was a awesome amount of work y'all have done. One of the things that I long time ago in a galaxy far, far away, I did write some analyzers. There is let me share my screen here. Haven't upkept this in very long time. As you can see, this repo is quite old, about 4 years ago. There's kind of a need for security analyzers in the F# space. I know a lot of people clamor for wanting to have some type of compliance, hitting some type of compliance thing, saying you can do some type of scanning. And so I'd say if people are very interested in that, this repository can be the house for a lot of that. And it probably needs a lot of work, since Florian and David have done this kind of stuff, or have made the analyzers a lot better. So I'd probably need to do some housekeeping here, but I think this would be a great place if anyone else is looking for a thing to contribute to. This would be a place to start. There are many examples of other C# Roslyn analyzers that deal with security related stuff, and we could basically start making ports of that. That would be probably the first place to kind of work on. With that, Does anyone else have any other questions or anything they'd like to talk about before we call it a close?
Maybe. Hi everyone. Maybe I think not technical stuff, but I always ask myself, so what's the so why should I have the requirement for such a thing? And there are several reasons, but I think this is so for me. I think it should be quite limited, to be honest, because I mean, this is, as I said, not a technical discussion. It's really more like a what's the story behind such an analyzer. So the example that you had, David, it was more like it's a fix for a broken API, I would say. Yeah. So you have a string comparison. You should always use an overload that takes a string comparison to be clear what you want or what the user wants, but the API also exposes a way of just using a default, which is not good. I mean, now either you should say the API you use should not work with a default, so that the user always has to specify a string comparison mode, which is the overload that you enforce with your analyzer, or it's okay to have a default, then you should not need an analyzer. So I'm not sure if you if it was clear, but in that case, it just looks like, okay, the analyzer is just a warning for a not well-designed API. And also in general, so I think that in general, it is always a little bit strange if you analyze code, which is usually not very sensitive to context. It's not context aware. So you write an analyzer, but the analyzer does not understand the requirements of your program. And this also, from my perspective, limits the use cases, this really sensible use cases for analyzers, because doing context insensitive checks is not very valuable from my point of view. I mean, it's either you are using a language which has some flaws, yeah, which you can do some stuff, but you should not do, yeah, or you simply do not need those analyzers. This is my experience of these things. So I was working in various projects where a bunch of all available analyzers were thrown on these projects, but I found them to be not very useful. I do not say it's not useful at all. There are probably some things that you can check, or you have found out that it's good to have a kind of warning or whatever. But yeah, that's a very general discussion, which I find really interesting, apart from the technical.
Yeah, I mean, it's a fair critique to say that the string API is you can call it broken or badly designed, however strong you want to word it, but it's out there, and it won't break compatibility to the past. So that's where analyzers can help you at least deal with the current situation. And yeah, I mean, in the end, we are dealing with an imperfect world, and analyzers can help in some situations, dealing with it. That's one point of saying analyzers have a right to exist. There were other things like you want to have in some restricted environment, for example, if you write health life science software, for example, or some health related software, and you are in a restricted environment by laws, there are also issues that you can address with analyzers. Yeah, there are just various reasons to be okay with analyzers. Given your critique that then analyzer doesn't understand the context, yeah, that's correct. I mean, you have to be really sophisticated to understand it. Yeah, maybe that's where AI and learning based approaches come into play and can help at some point. Yeah, it's just I mean, in the end, it's a tool with pros and cons, and yeah, we still think that they are valuable in many situations to have. So
Can I provide one more perspective, maybe?
sure.
Like F# is a very general language. It can be used in a plethora of ways. And people and teams, they have opinions. They have their own way how they want to use F# and not the full scope of it. So I can perfectly imagine an opinionated analyzer which will say, do not use mutation on arrays, which will never make it to the language itself, because like it's not that everybody accepts it, but there might be a particular team which likes to use F# in a way which basically intentionally narrows what you can do. Basically restrict the language to your personal opinions. So I think this would be like a perfect place, because such a change will never make it to the compiler code base, would never be accepted, but your own team can decide, yes, we write F# in a very specific way. We know we are special, but we want to enforce it. Yeah, or maybe allocations or enforcing types to be structs. Yeah, those are all opinionated ways which a certain team or project may demand. And I think analyzers would be like perfect fit for these like highly subjective situations.
That's a good point. Yeah. Also, maybe in the same direction as you just said, would be so I had some stuff going on with quotations or computation expressions which were compiled to quotations. And in that case, you would not understand if it's actually possible to compile the quotation, and you could use an analyzer to pre-check some stuff and say, hey, you are I don't know using some things which are not able to compile to whatever when you're using quotations. That could also be an interesting use case.
Yeah, like here's an example of a perfectly like this is not going to make it into the language, but I personally value this as something that I would do in all of my code bases is explicitly type your ignore statements. So every time you pass something to ignore, you can it doesn't take a type argument. I personally like putting a type argument on that. That means so if the code changes and I just ignore something different, I'm not ignoring like a partially applied function anymore or something. I'm not ignoring an actual like side effect. I'm ignoring or if I don't have an explicitly typed argument, I could potentially be ignoring like a partially applied function, and I don't want that to happen. So I explicitly type those things. And that's something that's not going to make it to the F# compiler, but that's something I would personally want an analyzer for. And I might even write that this weekend. So we do have a question from Richard Webb. Let's see what, let me go ahead and read this. On the subject of security analyzers, one of the reasons I was looking at integration with things like Sonar, which don't have much support, is they're not really active third-party attempts at integrations, kind of like Scott Washlin's Sonar plugin, which might not work for Sonar. Yeah, that's definitely, it's one of those like people want this, but who's going to do the work kind of thing is like if you have like a personal vested interest in doing it, I definitely recommend us collaborating on working on this kind of thing because so the only reason these kinds of things are really needed is like this. Sure, there are some security concerns, but a lot of it turns out to be compliance related, and compliance and security are not the same. Sorry to burst anyone's bubble. I know some people are going to be mad about that. That's what it is. But if we want to actually have a thriving security analyzers place, we can make that happen. And I definitely encourage anyone to get involved in that.
Yeah, it is about compliance, to be honest.
Yep, I feel it. I know.
The powers that be at work like having the results put into the sonar reports of all the graphs and charts and all that sort of thing. So,
And if I don't know if Sonar has plugin for Serif, it seems like Serif is a pretty standard thing. So if it can consume Serif,
I believe it does. I haven't tested it.
yeah, I would be shocked if that is not able to consume Serif. Like that would be a very shocking thing. Or at least someone hasn't written a Serif to Sonar converter. Like that would, I'm sure that exists. If it doesn't, that would be even more shocking.
No, it does support the leaf.
They do have their own generic formats for everything.
Of course.
Not as well as the specific ones, I think.
All right, anyone else? Going once, going twice. All right, well, thank you, everyone. Thank you to David and Florian for coming on and showing us the work they've made on FSharp.Analyzers. Again, if you'd like to come join our mission statement or come join us, you can come to the FSharp Amplifying FSharp page, click join us, and you can fill out the form, enter your name, your time zone, your topic, and we will schedule a topic with you or schedule a session with you. And also you can come and look at all our sessions that we've previously done on our sessions page, as well as you can go to our YouTube page and find all our sessions as well. All right, thanks everyone, and have a good day.